Hi guys, welcome to biology video 1.3. We're going to run through some stuff about chemical reactions today. We're still in that chemistry unit with some basic stuff that hopefully you remember from last year in chemistry. So chemical reactions, basically anytime we rearrange something, we have got a substance and it turns into another substance, or maybe two substances and they change into another substance. That is a chemical reaction. We also call this a chemical change. So the example here, like something like rusting, if something's burning, if food is cooking, all of those are sort of chemical reactions that are around us every day, where it's one substance, so it's iron, and then it combines with oxygen and it turns into iron oxide. So it's a new substance. It's not the same thing at the end. That's a chemical reaction, or we sometimes refer to that as a chemical change. Any chemical change involves some sort of chemical reaction. Now that's different than a physical change, because in a physical change, the form of something is changing, but it's not changing what it actually is. So like in this case here, we've got ice melting, and so it's water at the beginning, and it's water at the end again. So there's no real change in its actual substance. Its form is changing, but it's not changing what it is. This is true if we break something or cut something into smaller pieces. It doesn't change its substance, it just changes the form that it's in. So a chemical equation, there are a lot of different parts of a chemical equation. So I want you to, as we go through this, make sure that you know the parts. So everything on the left-hand side here, this is a reactant, okay? If we were thinking about this in sort of layman's non-science terms, we'd think about those as ingredients. On the right-hand side of the reaction is always the products. Now, in this case, we've only got one product, but there could be two products, there could be 20 products. It doesn't really, there's not a set amount, but anything on the right of the arrow has to be a product. Anything on the left of the arrow is a reactant. So the arrow itself, okay, the chemical reaction arrow that everybody knows, that means yields or produces or results in, any of those things. And a couple other quick terms about a chemical reaction. The big numbers in front of the compounds, so like we've got nitrogen and hydrogen, the big number in front of it is a coefficient. In chemistry terms, that means how many moles or how many molecules of that thing there is. The little numbers are subscripts, and the subscripts, remember, tell us how many of that element there are. So like there are 3 hydrogens here, and since there's no subscript, there's only 1 nitrogen there. Over here, there's 2 nitrogens in this one, and then there's 2 hydrogens here. And the way this works mathematically is that we multiply the coefficient by the subscript, okay? And that's going to help us in the next thing that we're going to have to do. So the law of conservation of mass says that in a regular chemical reaction, we don't create or destroy matter. In other words, we have to, if we have 34 grams on the reactant side, we have to have 34 grams on the product side as well. Now, what that means for us in terms of things that we actually have to do in a chemical reaction is it means we're going to balance our equations. Okay, and again, you probably did some of this in middle school or maybe in chemistry class last year. And so here's how we balance equations. I'm going to do this in sort of the simplest way we can. And really, if you need help with this, go online to the YouTube videos and look up the chemistry one. Go to Arnold Science and look up chemistry vodcast for balancing, and it'll get you right there. But basically, to balance equations, it means we have to have the same number of stuff on the left-hand side as the right-hand side. So nitrogen and hydrogen on the left-hand side, nitrogen and hydrogen on the right-hand side, and we're going to write how many of each thing we have. So I've got 2 nitrogens over here and 2 hydrogens right now, 2 and 2. On the product side, I've got 1 nitrogen right now, okay, and 3 hydrogens. And so our goal is that I want these two things to be equal. I want my nitrogens here, to equal my nitrogens over here, and I want my hydrogens over here to equal my hydrogens here. So here's the big rule in balancing. You can't change these numbers, the subscripts, you can't ever change those. All you can do is put coefficients in front of stuff. Okay? So that's what we're going to do here. We're going to put some coefficients in front of these things. And so basically, since I know that I've got an odd number here and an even number here, I'm going to make this even. And the way that I'm going to do that is sort of the simplest possible way is I'm going to put a 2 in front of this. Now this 2, this coefficient, it distributes just like it would in a math problem. So that means I've got 2 times the 1 that's here. That's going to give me 2 nitrogens. And then 2 times 3 gives me 6 hydrogens. Now, the good news is I already balanced my nitrogens then, right? I've got 2 and 2, golden. But now I need to balance my hydrogens. I've got 2 over here and I've got 6 over here. So the easiest thing to do then is to say, well, I need to put something in front of this that's going to make it 6. What times 2 makes it 6? That's 3. 3 times 2 gives me 6. Oops, sorry guys. Lost my pen there for a second. That gives me 6 hydrogens, and now everything is balanced. So this is a balanced chemical equation. And if we go back a couple of slides, you'll see that that's what we had when we started with. We had a 3 and a 2, and so we balanced those. So we're going to practice a few of those in class. So you always got to balance. Law of conservation of mass says got to balance everything. So a couple of quick hits about energy. Now, this might seem like some complicated stuff, but we're going to get into it a lot more when we get deeper into cells. Basically, anytime we have a reaction, we have to have what's called an activation energy, okay? Over here on this graph here, this is the activation energy. The energy from here to here is my activation energy. That's the energy that's required to get my reactants to turn into products. Now, why does that matter so much for us in biology? Well, in biology, we need catalysts to lower the activation energy. In biology, we've got all these reactions going on inside of a cell, inside of an organism, and they might happen, but they would happen really slowly if left on their own. So in chemistry, there's these terms called catalysts, and what a catalyst does is a catalyst basically lowers the energy, okay? In other words, whereas I normally have this big amount of energy here, if I had a catalyst, I might be from my reactants to my products, it might be something like that. It might lower it, okay? So let me just put a little arrow here. This is with a catalyst. I better write that. Okay, so with the catalyst. Now, in biology, catalysts have a special name, and you've probably heard this name before. Biological catalysts are called enzymes, and that's what enzymes do. Enzymes take what would be what would require a lot of energy, and they lower the energy level. In fact, a lot of catalysts will lower the energy level a lot, and so they might bring it down to something like this. It might require almost no energy once there's an enzyme there to lower the activation energy. Now, how do enzymes actually work? Again, you probably saw this stuff in middle school, but just to make sure that you know all the terms here. So our reactants are called substrates. In fact, let me write that down there. Okay, we'll call that our reactants. In biological terms, we call them the substrate. The enzyme is this big old gray spot here. And so the substrate basically comes in and it locks into a part of the enzyme called the active site. Once that happens, the enzyme then goes to work on it and it breaks it up. And then this part over here, okay, this would now be our products, okay? Now, why does this have to happen? Well, the reactants might turn into the products on their own, but it might require a lot of energy. And so the enzyme basically gives it a place to lock in and lowers the activation energy so that that reaction can happen. All right, that's a few quick hits. So I think we got one more video to cover on chemistry for biology, and then we're going to jump straight into cells after that.